I know it does not quite look like water, but at least we got the simulation right. Hey everyone, I'm Samak Agarkar and welcome to Agarkar Media Academy. This is the 34th video in Blender tutorial series for beginners, and in this video we're going to look at water simulation or fluid simulation inside of Blender. So in the last tutorial we saw fire simulation or smoke simulation inside of Blender, and in this video, as I've promised, we are going to look at fluid simulations in Blender. So I'm basically using Blender 2.83 version, which is a long-term support version. Last time we did the fire test. Now this time I had the liquid test open, and that was the result of 5 seconds videos from the same. Now, fluid simulation is also quite similar to that of smoke simulation, only the settings are different, and there are a few things here and there which you need to just consider. Okay, so this time, yes, we are going to use the default cube as well, but let me still delete the default cube. I just don't like the default cube. I don't know why. Now let's add a torus again. This time, yes, in the video I had used a sphere, icosphere or UV sphere, I think, but here I'm just going to use the torus because in the last video itself also we used the torus. So I'm just going to grab it in z direction upwards now, and this time we are not going to go through the object properties, and right here we had the quick effects right here, right, and here we use the smoke. Also here you can see that there is a quick liquid option also, but we are not going to go through the shortcut process. We are just going to understand everything inside of Blender in this video. Okay, so uh, I have selected the torus here, the object which I want to be as a flow object. Okay, so I go to the physics properties here, and inside of fluid I just click on fluid. Now here I have the fluid type. We want this to be of type flow. Okay, flow. So we have this of type flow. Here in the flow type we want liquid. This time we had used fire and smoke last time. Now we are going to use liquid. Okay, so as soon as I change to liquid, there are few changes right here in the settings, so which we can also understand. Okay, we are not going to go through that. We just want this surface emission to be 0.5, let's say, for a start. We are just going to go through what actually happens and when. Okay, initial velocity we can have, we may not have, it makes no difference at all. Okay, here in the flow behavior we don't want geometry, because what geometry will do is only the volume of the torus would drop as water. Okay, what as if it is on geometry, then only the volume of the torus will drop down as water. Only the volume of torus will drop down as water. We don't want that. We want a continuous stream of water, right? So inside of behavior here, flow behavior, we are just going to go for inflow. There's also outflow. Basically what, in the domain, whatever brings in the water or liquid is the inflow. Whatever takes out the water is outflow. So basically if you have an outflow, then whenever some liquid touches it, it will just disappear. Okay, disappear means it will be vanished from um the domain box. Okay, so that is the use of inflow, outflow and geometry. So by default it is at geometry, we want it to be as inflow. Okay, that is one thing. Now we don't have a domain as of now, right? So let's add a domain. Let's bring in a cube and let's just grab it, z it 1. Okay, let's just scale it upwards, and here I'm going to use the proportional the 3D cursor as pivot point, and maybe till here, and we are just going to grab it. Sorry, not grab, I want scale it in, not z, that is shift z. Okay, shift z direction basically scales it in every direction except z. Okay, so that was it. Now we are just going to go for fluid. This object also we want as fluid, but as domain, right? Type domain, right? As soon as we give it a domain type, it just disappears. We are just going to grab it upwards a little bit so that we can have something to work with. We are just going to play with the settings of the domain. So here we don't want gas, of course. We want domain type to be as liquid, right? Now as soon as there is liquid, There are so many things that have been changed, and we're just going to go through everything. Okay, instead of particle, just turn on these three. There are some, this is for bubbles and splashes and some everything. So this is what is useful sometimes, and it is just going to give you some cool results. Okay, so I think the resolution right now is at 32, and we are not going to increase the resolution just yet. Just here, that simulation method, this is just tip. uh, what we can do here is that we can decrease the particle radius to 0.5. Sampling can be 3 or so. We are just going to keep the randomness there, and I think that is it. We don't want anything else to be happening right here. And okay, so and the same thing that we saw for the cache, replay, modular, replay, and final. Okay, so we are just going to have it at replay as of now. Let's just keep it to 120 frames, which is about 5 seconds, exactly 5 seconds, to be precise, if we are using 24 frames per second, which is by default. Okay, so what we can now do is just play it, and of course you cannot see anything because we need to go to wireframe mode. Okay, so hopefully something happens. Give me something, come on dude. This is at flow, this is at domain, everything is right except it's not working. Let's figure out what's happening. Okay, so here in the mesh, we are just going to uh, make it okay. Okay, now we are just going to go back and play, and something should happen, but it is not, and I'm not sure what and why is this happening. Okay, let's just look at all the settings. The domain is of liquid type, it is correct. This is of inflow type, subsampling, substeps. I don't know if I can just keep it there. Can we put it 0? And let's go to, are we at modular, because that's one of the reasons why it may not be happening. Let's go to modular, and let's again go back to replay so that we have a refreshing. Okay, replay. Yes, now it's working. Cool. Just turn off the mesh and just play it, and now you will see that. See, we saw that there only the volume is being dropped, and why is that there? Because we made it in flow. Maybe 0, use flow. I don't know. Maybe initial z velocity is required. Go back. Just go down. Make it modular. Make it replay again, and from the beginning and start. Yes, now this is working. Okay, so you can see the particles that we had put right here. These are the particles which we can see, and it's going to give a really cool looking simulation, right? Now just wait till this frame is over. It is only till 120, so we don't need to worry too much about it. Let it complete once. It is almost near, and done. Now you can see it has been cached, and now you can see the particles are looking really great, and the water simulation is looking really great. Now to get the mesh for the particle, you just need to turn on the mesh, and I think that should be it. Now when we come back to 0, the mesh would show up. Woohoo! This is so cool. We can just go to solid mode, and here you can see it is looking really great, right? Now of course you can see the subdivision level is very low, right? It is very blocky, and uh, that is because of this division resolution, right? So if I make it, let's say 64, which is double of it, and 64 was what I had used during the last render that I had shown you. Let's go back and play it, and now it is going to be very very cool. And of course understand that the tub that I made was just a cube, and I just extruded it and just made it a tub like shape. That is not really the part, right? It is all about domain. So if the domain is right, and then everything else would just look perfect. Okay, so water simulation, we have the water simulation right here, liquid simulation right here, and it is working really really great. Now the only thing that is remaining right here is just the uh, color of water. Water is of type glass, right? With an IOR of 1.33. IOR is in I think incident of refraction or something like that. So it is basically angle of refraction, where index of refraction, right? IOR is index of refraction. So basically how much refraction would be there in water. So the IOR for water is 1.33, for air is 1, and for glass or something like that is 1.4 or something like that. Okay, so just understand, we just need to give it a glass shader and just use an IOR of 1.33. Now, a problem is there that in EV, transmission is not that great. Okay, transmission, which is basically transparency, does not work that great. Okay, so the actual realism you would get only when you are using cycles rendering engine. Okay, so the video that you saw was an EV rendering engine, and I had not used the cycles rendering engine. Cycles rendering engine would give you much realistic looking visuals than the EV, but I just used EV because it is just faster. Now you can just imagine how much time it would take to render out these many quads. Okay, so that's why I did not use the cycles rendering engine. I used the EV rendering engine for the video. But of course, that this is what we have already said, that when you are going for the production level things or production level rendering, then of course you will be using subdivision, this resolution division of around um, 500 or so, right? Okay, so you're not going to use 64 or 100 or 200. You are may probably be going to using 500 or 1000 or even more, depending on what kind of look that you are going forward for. Okay, and of course these are not the renderings that are happening on your laptops or your systems. These renderings usually happen on render farms. So what render farms are basically, that we will be seeing in few 2 or 3 videos later, because once this simulation, physics simulation part is over, uh, render farms is one of the biggest thing that we need to understand when we are using any 3D software, whether it be Blender, Maya, 3ds Max, Cinema 4D, or any other. These rendering farms are very crucial in production levels. You cannot have your systems rendering out these videos forever, and you are just sitting and sleeping and drinking, because you cannot do any work on your laptop when some rendering is going on. Now you can see this is just calculating, and still I cannot click anywhere else, because if I click anywhere else, I know that for sure my laptop is going to crash. Okay, so, and already I am using OBS Studio, which is going on, which is recording this video. Plus this Blender is using the CPU for computing the water simulation. So I know that this kind of rendering and calculations are not to be done on your computer. Usually render farms are used, and render farms are basically companies which, not exactly companies, but you can basically hire a server for rendering your systems. We are going to look at what options are available, free as well as paid, and we are just going to look at what options are and what how to use them. Okay, so our water simulation is done, and you can see that the number of chords or number of polygons is so high that it is still giving me very low FPS. Okay, so you can understand what kind of work is there. Okay, you can see here there is 1 lakh faces, or 100,000 faces. Okay, now what we are going to do is, first of all, we are just going to shade it smooth, so that all it's at least a little bit smoother than the usual. Now in the rendered part you can see that it is just a plain old white material. Okay, so we are going to give it a shading as we have already discussed. Just go for new node, right? And we are just going to delete this principal BSDF mostly because we don't want it. Then we are just going to go for glass shader. Where is the glass shader? Search for glass BSDF, and you're just going to heat up to the surface. Color will be a little bit of blue, and IOR will be 1.33. Okay, so now I am in EV rendering engine. Yeah, one more thing, to make it work in EV, you just need to go to the materials tab here, and inside of settings you just need to use alpha hashed, and also for the shadows alpha hashed. Okay, so there is some kind of refractions that can happen. Just turn on the sub screen space refractions and subsurface translucency. Okay, refraction depth you can just increase it a little bit. Now I'm just going to add a mesh at the bottom so that we can see if there is some transparency going on. Well, there is not much transparency going on because EV is, as I've already told you, not good for transparency. Okay, there's some kind of transparency that you can see, but it's not that great. Okay, so we are not going to worry too much about it. What we are going to do is, yeah, turn on the refraction. So now you can see there is some refraction going on, but there is no good transparency going on. Okay, so if you just go to EV to cycles rendering engine, then it would be clear that water looks like water. Okay, so here you can see the blue is too much of blue. Just going to decrease the blue a little bit so that it looks water, not something else. Okay, cool. I think that would not green, not green, something like that. Okay, and if I just render an image out of it, you could see that it looks really, this would be to render. I still don't want to render out everything because I know it's not going to work. So you can already see that water looks great right here, and it looks watery, but not the see here. You see it looks like water, not quite water, but you can see that there is too many fireflies. These are, as we have already discussed, this is called as fireflies. How can you remove the fireflies? You have two or three main options. One, to turn off the refraction. If there is no refraction, there would be less fireflies. This is something called as acoustics. Acoustics give very realistic looking renders. So when light travels through a glass or a transparent or a translucent medium, then it basically causes acoustics, light acoustics. So that is the biggest cause of fireflies like these, as you can see right here and here. It is the biggest cause of fireflies. To reduce fireflies, either you can turn off the acoustics, to just don't use any transparent or translucent shaders at all. 3, increase the samples in the render. Here we are using 128. Maybe if we go for 1000 or so, 500 or 1000 or so, the more the samples, the less would be the fireflies. And 4th, denoising inside of this one. So here we have denoising node, denoising this one. Now it is not a node, it is an option. Okay, denoising option, or as we have already seen in one of the videos, you can use the denoising data and then composite it in the compositing node to give it a realistic looking or cleaner image basically, to remove the fireflies. So this is all about water. We are now almost done with water. There are a few different things which you can play with. Of course, for this video which I have seen shown you, this is for the blend. This is using EV rendering engine. That's why the water is not looking water. It's looking some kind of glue, translucent glue. And this is just a tub which I extruded from a cube. So no big deal there. It's just that you need to understand how to work with water. once you know how to work with water, there's so many things that you can do. Of course, now for this one, one last thing that we want to do is, this one is using water which is going downwards. So basically the gravity is making it fall. We want a fountain, we want to put it upwards, right? So first, what we need to do is first go to the edit mode, because this is the domain that we need to first work around with. We're just going to scale it in, not this one, scale it in z direction, because we want some to have some sort of space to work around with. Not grab, why am I using grab? Scale z. And so I've just scaled it upwards. Now what I'm going to do is I'm going to go for the wireframe mode and just uh, now this is of course going to give you some odd results, because we have seen once, whenever you scale the domain or you do some settings with domain, you need to refresh it, and there is no good way of refreshing it. Okay, so first of all we are just going to select our torus, which is the flow, right? Inside of there, we are what we are going to do is we are just going to give it an initial velocity of z. Okay, so here inside z, I'm just going to go for, let's say, 2. I have no idea how it would work, but we are just going to do it. Okay, now I am going at the very bottom, make it modular, and then make it replay again, so that we have a refreshed model. Okay, let's go to the first frame, and let's just play it from here for 120 seconds. We have no, yeah, so here you can see it's looking cool. The water is going upwards. If it is going too much higher, then we would have to decrease the initial velocity, but basically you got the point what I wanted to tell, right? So initial velocity, this is the same for fire and smoke also. If you have an initial velocity, then you can just move it somewhere else. Okay, so that is it, I think. Now this would of course take too much time to happen, or to complete. And I think the water is hitting the wall also. So what we are going to do is, uh, now I'm not going to tell you what to do, because we've already seen what how to do it. And once you are used to how to do it, I don't think there is much uh, requirement of doing it again. What am I saying? Yeah, so basically what I mean to say is, once I've shown you what to do, now there is no need for me to make it again, right? Now of course it's not pausing because it's rendering out and it's slow kind of, right? Yeah, so now it paused. Yes, okay, cool. So we had already discussed, the water is hitting the ceiling, which we don't want. Maybe that's because of the velocity. So just decrease the velocity, play along with these fields. Just select the torus and just play along with the velocity. Maybe 0.5 would do. I have no idea what would work and what would not. But just one thing, that whenever you make changes to anything other than the domain, then you just need to go to the domain, make it modular, and make it replay again, so that you can see what's going on. Okay, because otherwise it won't work. That's one of the downfalls of how these things work. I think the velocity is now is not that high, and it will just fall. Yes, so now it's falling, and now it's looking really great. Okay, so you got the point. You can have small tubes, which are just going to splatter the water everywhere else, and that's how you create a fountain. So here you can see a very cool looking fountain is being made, and that's looking really really great. And I think that is it for this video. We have covered two simulations right now. One, we covered the smoke simulation, and now here we covered the water simulation, and we also made a very cool looking fountain. Just render it out in EV. If you render it out in EV, the transparency would not that be great. If you render it out in cycles, it would take too long to render it out, but the results would be much 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 better. Okay, and it would just look realistic, almost realistic, so you don't need to worry about that. Okay, in the next tutorial what we are going to learn is, we are done with water, we are done with smoke. we are going to make a cloth simulation. Okay, cloth simulation. So for the cloth simulation, we basically have two things to work with, and I'm just going to show you all of them. So the cloth simulation part would be divided into two parts. One for the single cloth simulation, basic cloth simulation, and the second one is for some additional things that we can use inside of Blender to give good looks to our cloth. Of course, those are the same things that we could have also used for water as well as smoke simulation, but just the problem is that my laptop is not going to handle so much of things at once, so we did not try even. Okay, but when we you when sorry, when we go for cloth, then it becomes really easy because the is not going to have so many vertices to work with. Okay, cloth is going to have very limited vertices, and that would be easier for my laptop to simulate, and thus I could then show you what's actually going on. Okay, so I hope you learned something great from this video. I am planning to start a Discord server where we can just you know uh, come in and discuss whatever problems that we have and stuff like that, and we can also share the work that we are doing, and that would just create a community for our ourselves, right? So I'm planning to make a Discord server. I'll just update whenever I have the Discord server ready. Okay, and thank you for watching this video. See you in the next video. Till then, keep smiling and keep learning.